Now that we have our class declared, we can actually use it in our program. We declare a new instance of a class. We declare a new instance of a class by starting with a variable name, the same way we declare anything, and setting it equal to the name of the class, followed by a pair of parentheses. Later on, we'll talk about what might go inside those parentheses, but for now, just worry about following it with an empty set of parentheses. Now you'll notice that I've put person in bold and purple, which is the way we usually designate function calls. But person is a class. The reason I put it in purple, though, is that when we call it, it actually calls our init function. This creates a new instance of this class and then returns that instance to be set equal to the variable name on the left, in this case, myPerson. So after executing line 12, myPerson is a new variable, and its value are the default values associated with person. We can access them using the same dot syntax we've seen in the past. myPerson dot firstName returns the value of firstName from inside that instance. By default, the value of firstName is no firstName in brackets, and so that's the value that's returned when we print the value of myPerson dot firstName. The same thing follows for last name, eye color, and age. All those values match the default values that we saw over here. So what happens here is that calling person like this calls the init function, and as part of those lines, it creates these 4 variable names. Preceding it with the word self means that these should continue to exist even after the init method is done. The code proceeds after init is done running, but because those were all preceded by the keyword self, those variable names all continue to exist. Self defines them for the purpose of this instance of person, and this instance of person was just set equal to myPerson. So calling myPerson dot firstName gets the value of the variable firstName as it was assigned to that instance using the keyword self. Now once we've created it, we can modify them just like any other variable. So here we create myPerson and set it equal to a new instance of person, and we print myPerson.firstName and see, as expected, the default value for firstName. myPerson.firstName is just a way of accessing the firstName variable inside the myPerson variable, but it's really just like any other variable. And just like any other variable, we can reassign it to a different value. So here myPerson.firstName equals David changes the value of firstName to David. And so when we print it, we now see David as the value of myPerson.firstName. Now again, strings are immutable, but we're not actually changing the value of the string here. We're just changing what string firstName points to. But what about our more complex example where we had separate classes for name and for person? Well, here we just extend the exact same reasoning. On line 15, we create a new instance of person and set it equal to the variable name myPerson. And then on line 17, we print myPerson.name.firstName. We use name now because name is the variable being declared inside the init method under person. But what is name? Well, name is a different class. It's a different type of object. And it itself is made up of 2 variables, first name and last name. So to get the first name, we have to call my name. So to get the first name, we have to call name.firstName, and it prints the exact same thing we saw before. So to take this step by step, calling myPerson.name retrieves the instance of name corresponding to myPerson. But once it has it, it's just as if we grabbed it on its own. And we can call that .firstName to get the firstName variable out of the object. And modifying it is the same thing as it was before as well. We call myPerson.name.firstName. Once we've called that, it's just like accessing any other variable. And we can assign it to a new value. So here we assign it to David, and then we print the new value and see that sure enough, its value is now David. For the most part, we're going to stick with only one class just for simplicity, but this echoes the kind of complexity we can build using object-oriented programming. We could create lots of different classes and use them to represent lots of different things, all of which are connected. The power of object-oriented programming comes from the ability to have multiple instances of the same class or of the same data type. We didn't create the class person just to be able to create only one person. We created it to be able to keep multiple people in memory. So here, we define 2 different instances of the person class, myPerson1 and myPerson2. We create each of them the same way, but calling it twice generates 2 different instances. In other words, it creates 2 different people. So myPerson1 and myPerson2 are 2 different people. If we change myPerson1.firstName to David and myPerson2.firstName to Vaishali, we see that those are changed independently. myPerson1 now has the first name of David, and myPerson2 now has the first name of Vaishali. Changing the first name of one of them didn't impact the first name of the other one. In that way, they're just like multiple variables for anything else we've talked about in the past. Changing one variable doesn't impact another one unless at some point we've set the variables equal to each other. So in this way, we could create lots and lots of different instances of people. We could create lists of people and just have class rosters. And yet each item in those rosters would still have a pretty complex structure. They have names and eye colors and ages. So that's the power of object-oriented programming. It allows us to manipulate data and organize data more intuitively.